Here's what's coming today on the Woodworking Network podcast.
And that's the other thing you've got to look at. If you've got an asset and the controls are shot on it, it has really no real resale value. So it's either going to be a boat anchor in the back part of your parking lot, or you can update it, upgrade it, and actually get some use out of it.
Welcome to this episode of the Woodworking Network podcast. Join us as we explore the business of woodworking, big and small, and what it takes to succeed. I'm Will Sampson. Today's episode is sponsored by FDMC Magazine. My guest is John Mitteer, a senior sales consultant at MacMotion, a company that specializes in rebuilding CNC machines. But first, I want to talk about what is really disposable. Lots of people talk about how we live in a disposable economy. What they're really talking about is how fewer and fewer things are repaired or rebuilt. Instead, the focus is on throwing things away and replacing them with something new. That's supposed to be really good for the economy because it increases demand for new products. But I'm not so sure. For better or for worse, I'm a product of parents who survived the Great Depression. Growing up in the boom times of the early 1960s, we didn't want for anything. But we sure weren't going to throw something away if there might be a use for it, or if someone else might have a use for it. Today, in my adopted home state of Maine, there is a popular expression that sums up a Yankee philosophy of frugality. Folks here are fond of saying, use it up, wear it out, make it do, or do without. That's a little different than trading in your cell phone to get the latest model, and heaven help you if your battery dies before then. Can you even replace the battery? When it comes to our businesses, the disposable trend runs up against business calculations. I've been in more woodworking shops than I can count, where the walls were covered with all sorts of dusty jigs and fixtures that were used just once. But no one wants to throw them away because we might just need that one of these days. Of course, whether they can even find it when they need it, that's another story. When I first got interested in woodworking as a hobbyist, there were all sorts of people who revered old cast iron machines, saying, they don't make them like that anymore. But some of the reasons they don't make those machines anymore is that new machines can do so much more, capitalizing on computers and software and a level of precision unmatched by those old cast iron behemoths. But then we're dealing with a different kind of discussion. What about software and hardware updates to stay current? What requires special training and equipment? When machinery costs tens of thousands of dollars, how do you budget for repairs and replacements? How do you create a timeline for upgrades? When do you decide to upgrade? When do you decide to replace? There are no pat answers to these questions, but the point is the questions themselves are not being asked enough. People used to talk about planned obsolescence. This is obsolescence without a plan. The next time you think about a new machinery purchase, think not only about the return on investment, but also the lifespan and how that value might be extended over time. Before we get to our interview with John Mitteer, let's pause for a word from our sponsor. FDMC Magazine is your vital source of information to improve your woodworking business. Whether it's keeping you apprised of the latest advances in manufacturing, helping you solve your wood technology problems with Jing Wangert, or inspiring you with case histories about successful businesses and best practices, FDMC Magazine is there to be the sharpest business tool in your shop. Learn more and subscribe for free at woodworkingnetwork.com/FDMC. Now let's talk with John Mitteer. Today our guest is John Mitteer, who is a seasoned manufacturing professional with over 3 decades of experience in various industries, including defense, automotive manufacturing, and automation. He is currently serving as the senior sales consultant at MacMotion, a company that specializes in rebuilding CNC machines. Welcome to the Woodworking Network podcast, John.
Well, thank you for having me. Appreciate it.
Well, we enjoyed having you at IWF on our CNC boot camp, and you shared a lot of interesting information that I think that deserves a wider audience. I think a lot of our Woodworking Network audience doesn't really even understand the potential of rebuilding their CNC machines rather than replacing them. What's involved in rebuilding a CNC machine?
Well, there are typically two parts to the machine. You have what we call the bones, which is the mechanics of the machine, and then we have the brains, which is the control side of the machine. And when you're talking about the mechanicals, it is dependent upon the machine and the machine type. Obviously, for the wood industry, we're dealing mostly with routers. So it's a lot of bearings, it's a lot of slides and guides and trucks and spindles and that types of things. On the brain side, it really doesn't matter what type of machine. The brains are the brains. And if it's a machine that's in the metalworking industry or in the woodworking industry, it's servos, it's controls, it's a complex dance, so to speak, of replacing the brains to match what the mechanicals can do.
Now, what kinds of machines are good candidates for a rebuild?
Well, really all what I call quality machines are candidates for rebuild. And that goes beyond the woodworking industry, that goes to metalworking as well. If you've got a good frame, and that could be a very old frame. I've done machines that were made for World War II, and those are great iron. And if you got good iron, then it's really uh, advantageous to just rework what you've got and then go forward with that. So on the side of in the woodworking in the routers, so to speak, I always look at a frame. If a frame's a heavy frame, you kind of get what you buy. And if you buy something that's heavy and well built, then it's definitely worth retrofitting, rebuilding the mechanics of the machine.
Now, are all those parts and all available regularly? Or is there problems with rebuilding because of proprietary parts?
There are a few proprietary parts, but in this day and age, uh, anything is replaceable. I can reverse engineer anything. You've got the right equipment. You can use lasers. You can really make anything that you want. And with the advent of the internet and with making the proximity of getting parts available, there really isn't a part that you can't get if you just want to research it a little bit. 20 years ago, you didn't have this capability of looking worldwide for parts, but now it's basically get on your computer and look up a part number, and there it shows up, and away you go.
Wow. Things have changed.
Oh, yes. Yes, definitely.
Well, why should someone decide to rebuild their machine rather than replace it?
Well, you have an investment that you've already made. And typically, by the time you're getting around to looking at rebuilding it, it's paid off. It's basically fulfilled its function, but it's still an asset. It's still on your books, and you could take that expense that you would go for a new piece of equipment, and you could just update the machine you've got. The only advantage of buying a new piece of equipment is if it has features or benefits that you currently don't have within an existing piece of equipment. However, most older pieces of equipment can even have or be adapted to have those extra features added to them as well. So really, it's a cost savings overall. You can go somewhere between 70 to 50% of the cost savings over a new machine. That's the big advantage of doing that.
So let me get this straight. So you could actually, if the attraction of buying a new machine is, I want it to be faster and have the latest and greatest features, you could potentially take your old machine and upgrade it to have those kinds of capabilities. Is that correct?
That is correct. Up to a certain point. Obviously, there are some when the frame doesn't fit what you want to do going forward.
You
I
can't you
can't.
can't make a 4x8 machine into a
Yeah,
5x12.
Exactly, exactly. I've got several customers that they want to move up on table size, and you've hit the one of the big points in routers. I want something bigger. Well, I can't make a frame grow. Um, I can't do it cost effectively. Let's say I certainly could do that, but cost effectively, it doesn't make sense. And also with the advent of the internet, there is a plethora of used machines that are on the market. And you've got a lot of good iron out there that is relatively cheap, especially if the controls are shot. If the controls are bad, it's almost scrap value for the piece of equipment you've got. And that's the other thing you've got to look at. If you've got an asset and the controls are shot on it, it has really no real resale value. So it's either going to be a boat anchor in the back part of your parking lot, or you can update it, upgrade it, and actually get some use out of it. Understand that if you bought the machine for $100,000 20 years ago, the replacement cost on that is dramatically more today. So the cost savings of utilizing an existing asset is going to be pretty tremendous when you look at it overall. And you get what you want out of it going forward. You get a rebuilt, good frame. You may have a significant amount of money already spent on repair parts. So you've got that asset that you're going to be, if you get rid of the machine, you're going to be throwing that cost away. And you can continue on going forward. And also, the knowledge base of fixing that machine, your guys already know that machine. They know it inside and out. They know how to fix it. And that knowledge base is going to go away if you buy a new machine and you have to retrain your people on the preventative maintenance and rebuilding and fixing the machine as well.
That might also apply to relationship you might have had with the manufacturer of that machine too, and parts and things like that. If you go to a different company, you may have to change that too.
That is one of the, if you wanted to call it a negative, sometimes the OEMs are not very uh, happy about you going a different route than with them.
Yeah.
But again, if you do a little research, or if you have a good repair facility or company close to you, they can certainly repair your machine. There really isn't anything out there mechanically that I've seen that I have not been able to find the replacement parts or make the parts for. So I would never shy away from the OEM saying they're not going to support you, because there are other people that can and will.
That's good to know. Now, sort of turning that around, we talked about the machine size capabilities. Are there any other reasons that it might make more sense to replace the machine rather than rebuild it?
Well, you hit me with a tough question there. I really, unless it's some new feature that you don't have, um, uh, I don't. Well, okay. There is one area that you could say, if the mechanics have improved dramatically, so that you have increases in speed or the abilities because of that, the mechanics are not going to change. They're going to be what they are. A ball screw is going to be the ball screw it was. So if the new machine has a better ball screw and it's a faster ball screw, that's going to give you a competitive advantage of the new machine. But you also have to think about the cost of that new machine, because now you're going to have to amortize that cost over a number of years, rather than you can actually expense the cost of repairing a machine in in a current fiscal year, whereas you can't when you buy a new machine. You've got to expense that over time. So there's some advantages there.
What about, let's see, another thing we talked about the size of the machine capabilities. I would think if somebody was thinking about going to 4 or 5 axis and they have currently a 3 axis machine, that might be another case that is replacement. Or is that something that you can build into a rebuilt machine to add an additional axis?
You can, but you better have a pretty good sized machine to start with to justify the expense. When you go to 5 axes, that's additional. The 5 axes mechanism is pretty expensive, and you're not going to be able to rebuild that because you have to completely replace that. So it would have to be a fairly large expense to replace that machine to justify it. So I mean, if you if you want to have a 5-axis machine that the current cost is 150,000, you're going to be pretty hard pressed to rebuild a 3-axis machine and retrofit the controls and everything for about that same price. So there is a price cap, let's say, for any action that you're doing. And again, 5-axis gives you a totally different process capability that you're not going to get with a 3-axis machine.
Right, right, right. So it's not like replacing a spindle or upgrading a spindle or upgrading a controller.
Yeah, it is. That's a little more difficult. Can be done, and on a very large machine, like say you had a gantry machine, a big one. Now it's a 3-axis. Now there is justification for adding that expense because it becomes a smaller percentage of the overall replacement cost of the machine. Now we're talking about a machine that's going to be a $500,000 or $1 million or $1.5 million. Now you're talking about just adding, a 5-axis versus 3-axis head on the machine. So that's a significantly smaller portion overall of the cost of the machine. So then there'd be an advantage financially for doing that.
Well, getting back to what is more typical of somebody who has an existing 3-axis machine and wants to rebuild it and make it current, how long does it take to do a rebuild on a typical situation?
It depends on how you're doing it. Our company goes out on site and does the work there. So if we're doing both a mechanical rebuild and we're going to be doing the controls rebuild, that's typically a 2 to 3 week overall downtime in your shop. But we're doing everything right there. So we do a lot of preliminary work. We go out ahead of time. We measure everything. We make sure that we have everything that we need to replace or repair or if we have to redesign, then we do that as well. But it's all done ahead of time so that your downtime is minimal as much as you possibly can. Replacing a whole ball screw versus repairing a ball screw, there's a different time frame between the two of those. But the idea is to keep the downtime in your shop, your loss of production, to a minimal. And that's why we do it on site. Now, if you've got to pull your machine out and send it somewhere, that's going to be significantly more, probably more in the I'd say 6, 8 to 10 week time frame to do that. Plus, you've got the cost of moving the machine out, the rigging, all of that expense that's on top of that.
Well, that's still less time than I'm hearing on some of the back orders of some of the major companies that are bringing in machines from overseas.
It is. It is. I mean, I've heard, and some rebuilders are going to be in the 6-month time frame, and it depends upon what the production schedule is at the time. And that, it's getting better because parts are becoming more available, and depending on what you want to do with your machine. If we've got an order a new spindle, the time frame is really dependent upon the spindle delivery. So everything has got to be judged per machine, and it really doesn't matter what brand machine, but different brands have different requirements for the components that are going on them, and the availability is a variable that you have to look at when you're looking at time frame.
Well, now with Mac Motion, can you just sort of walk us through the process from first contact? Say I call you up and I say, I've got this, machine that I would like to consider rebuilding. What's the procedure? How does it go from there?
Well, we actually have standardized costing for most machines that are out there based upon spindle size, table size. So we would get a proposal to you, and then we would go on site and do an inspection, a health inspection, where we go through. It's typically a 45-point inspection. We're going through every part of the machine. We're checking for backlash. We're checking for spindle runout. We're checking for lost motion, checking the ball screw health, the slide health, all of the things that need to be or possibly need to be replaced. And then we'll write up a proposal based upon that is the items that have to be replaced or repaired on the mechanical side. While we're doing that, we're also doing the control side, where we replace all the motors, all the drives, all the cables, the electrical panel, and everything. And we do all the engineering ahead of time. So So with that information, we go back and then we build up the panels. We do all the mechanical stuff that we can ahead of time, and that takes about 6 to 8 weeks to do that. Then we ship the components out, and then we have a team that goes out. Mechanical goes through. They take off all the old controls and everything. Then they repair all the mechanical while the electrical team is putting all the new motors on, yeah, putting the new cabinet on, putting the new controller on, and getting everything wired up. So that process, normally, if you're just doing controls, is basically a 1 week turnaround. If you're doing a rebuild of the machine, that can take 2 to 3 weeks total. Just depends on how much of the mechanics that we have to do on the machine. And then there's always, there's always a possibility that you're going to run into something that you didn't see before. So we like to keep that 2 to 3 week window flexible a little bit. We want to do it as quickly as possible to get you back in and get you running so your production's back up.
Wow, that sounds like a fairly straightforward and surprisingly brisk process.
Well, we only do retrofits. It's our only business. It's the only thing we do. We don't build machinery. We don't, do anything else but do retrofits. We build the controls. They're built in Missouri. The engineering's done in Missouri. The control software is done in Missouri. So everything's done here in the States. And again, it's all we do, and we do it very well. So it really doesn't matter whether this is a router, a boring mill, a VTL, a VMC, anything that's CNC. This is the same plan for any type of machine that's a CNC that needs to have rebuilding and retrofitting done to it.
Well, it sounds great to me. It's one of the things where I think that people that are getting started with CNC, there's a little bit of a nervousness about this huge investment that they're making in the machinery and how long is it going to last and what am I going to have to do uh to keep it going and then eventually replace it and so much of our technology today, you got your iPhone and you can't even figure out how to change a battery in it. So
Yeah, that's one thing that technology doesn't stand still for us. It keeps moving forward. And so you have to keep pace with that. And that's another thing about our company is that we guarantee support for the life of the product, and we also guarantee non-obsolescence. So the the trap that a lot of companies are getting into is they buy a machine and it's very efficient and it's great and everything, but about the 5 to 6 year mark, they start having problems and they're not getting the support that they need, or get up to the 10 year mark and the controls are getting obsolete and are not supported anymore. That's where we support it for the life of the control, and we expect to be adding another 20 years of life to any piece of equipment that we touch. So 20 years life, 20 years of production. If you did a cost analysis and ROI on it, it would be a no-brainer because it just makes a lot of sense. It's a very cost effective and it's the best utilization of an existing asset that you already have.
wow, that sounds great. Well, I'm always glad to hear about things that are adding value and not just becoming a part of our disposable society.
Well, it's interesting you bring that up because that's the other one of the newer things that's coming out is they're talking about the green initiatives that we talk about. And when we start to talk about capital equipment green is the ability to rebuild equipment rather than replace it. So you're not having an effect on landfills. And I know it's a kind of a new thing to talk about in the machine rebuilding business, but it is becoming more and more popular, especially in higher priced capital equipment, that if you can retain and rebuild, it's better than replace. It's just better for the environment. It's just better overall. Um, and we just happen to be part of that little green thing that they're talking about now.
Well, it sounds like it's better for your bottom line too.
Yeah, absolutely. You bet.
Well, this has been really informative, John, and I appreciate your information. If folks want to learn more about MacMotion, what's MacMotion's website?
It's www Mock, MACHMOTION.com, mockmotion.com. And you can go to our website. We have lots of customer acknowledgments on there. We see a lot of videos of the equipment we've done. And again, we do all brands. It's not just one brand.
That's great. Well, thank you much. This has been very informative.
All right. Well, thank you for the opportunity.
That's it for today. If you're looking for more of our podcasts, you can find all of them at woodworkingnetwork.com/podcasts and in popular podcast channels. Be sure to subscribe so you don't miss a single episode. Thanks again to today's sponsor, FDMC Magazine. If you have a comment or topic you'd like us to explore, contact me at will.sampson@woodworkingnetwork.com. Thanks for listening.